Hello everybody and welcome back to another video. In this video, we will be covering a topic from linear algebra. And in this problem, we are finding the parametric representation of the plane that passes through these 3 points. Now, to start off, we must just visualize what a plane is. So if we draw this 3D, so this is your x-axis, this is your y-axis, and this is your z-axis, a plane would be just like the XY plane. This is going this way in this direction where it has a partial slope and it is spreading out. It's just this section of this 3D plane. Now that is what we are trying to define, and it passes through these points. So let's say this is our first point, this is our second point, and this is our third point. So it passes through all these points. Now, one way to represent a plane is parametrically. So let's say we want to represent a plane of lowercase p. So let's say p is equal to, we would say a parameter, which we can call t1, times our position vector, or not position vector, our direction vector 1. So that would be, in this case scenario, let's look at this point, or let's look at this point on the plane. That would be this way, hypothetically. And then this would be plus a second parameter, t2, times another direction vector. Let's say that's u2. So this covers any point on this plane. However, we have to get to this point. So we will look right here at the origin, and we will place our point at the origin and go up to our starting point. So this would be plus v, where these are all vectors. Now that is your equation for a plane. So you have your direction vector, you have your position vectors, and then 2 direction vectors, which can be multiplied by scalars to give you different points, which are all on this plane. Now, to solve this problem, we must use the idea that if you have a vector A and you subtract a vector B, and these are the 2 vectors. Let's say this is A, and then this is B. Vector A minus vector B is the same as starting at vector B and going up to the tip of vector A. So this is A minus B. So now, let's look at these points. So you have one point here, you have another point out here, or I guess it'd be up here, and then you have a third point, which would be out here somewhere. And then imagine we are in 3D. So we have this vector right here. Let's call this A, this B, this C. This vector right here would be B minus A. And this vector right here would be C minus A. And this vector from the origin, a direction vector, would just be vector A. So our equation would be our vector x is equal to c minus a, where this is multiplied by a scalar, t1, plus t2 times b minus a, plus vector a. So this is our parametric representation of a plane. Now, let's set this as our a, this is our b, and this is our c. So, for our first, let's call this u1, for our first direction vector, we have 2, 3, 6, minus 1, 1, 2. So this is 6 minus 2. This side is 4. This is 3 minus 1. This is 2. This is 2 minus 1. This is 1. So this is our u1, our first direction vector. Now u2 would be c minus a. So this is u2 is equal to negative 4, 6, 1, minus 1, 1, 2. So this minus this is negative 1. 6 minus 1 gives 5. Then negative 4 minus negative 4 minus 1 is negative 5. So this is our second direction vector. Now we know that our third direction vector is just vector A, as we just have to get to this point now, or our position vector, not direction vector. So we have that V is equal to 1, 1, 2. Now we can just use this equation to set up our plane. So let's call our plane X, and we say X is equal to T1, a parameter, times our first position vector, which is 1, 2, 4, plus T2 times our second direction vector, which is -5, 5, -1. So we have -5, 5, -1. And then plus our position vector, which is A, which is just 1, 1, 2. And this is our answer for our plane in parametric mode. I hope you all enjoyed this video, and thanks for watching, and I'll see you in the next one.